Hi everyone. Today we are going to discuss allocate minimum number of pages. This is marked as hard problem and this is one of the most important problem in binary search. Like if you understand these problems, you can binary search is very easy for you. So this is one of the most important questions. It is asked in many of the companies. बहुत कंपनी में पूछा गया है. Like if you see the company tags of this question, it's Infosys, Amazon, Microsoft, Google, Coordination, and even many of the companies ask this question. Like Flipkart also asked this question recently, and yeah, that's the thing. Like now, if you, now let me start the problem statement. Oh, it is marked as hard. Okay, you have n books, each with AI number of pages. Okay, him students need to be allocated contiguous manner, with each student getting at least one book out of all permutations. The goal is to find the permutation which the student with the most pages allocated to him gets the minimum number of pages. Okay, minimum number of pages. Note this down. Okay, out of all possible permutations. Return minus one if a valid statement is not possible, and allotment should be contiguous. Okay, in order. See the expression for better. Okay. Given that is 15, 17, 20. Let's take this example first. Okay, in this example that is 15, 17, 20. The given students is 2. As the given students is 2, what we have to do is we have to like we have to divide this in such a manner that it should be divided within two students, that is like one student or two students, like that. But the pages allocated should be minimum. Like if you see right here, if we divide this into 15 and 17, 20, so here the maximum of minimum, as the question states, that is the where the student most pages allocated to him, the minimum number of, like, find the permutation with the students, like they had given, it should be the minimum of the all maximums. So if we like 15 will be for one student and 17, 20 will be for another student. Like here 15 means the one student gets 15 and another student gets 17 plus 20, that's 37. Let us take 37 as one of the answer. Like let us take 37 would be one of the answer, but we can divide in this manner also, right? That is 15 plus 17, that is 32 and 20. But if we compare both the answers, we can say the minimum of the maximums is 32, right? So this would be the answer. So this is what the question states. It is like 32 is the answer. Now, like what would be the brute force? By seeing this question, how can you think of the brute force? As again, like here we cannot sort the array because we have to, like, it is given as a subsequence. We have to provide the subsequence. Like we have to provide subsequence, not sub array. Like we have to give sub array, not subsequence. Sub array means it is a part of array. Subsequence means you can take any element of the array. So that is the difference. Now what would be the brute force here? Like if we see the observation clearly, here 15, 17, and 20 for two students, like we can add all the students, like we can add all the pages, and we can check, like for each and every index what would be the right like maximum for two students, for three students. Like in this case, like they had given m is equal to 2, but they had given 4 array. Like we can check for first this element. Like for the second test case, we can check first, we'll divide 12 and 34, 17, 29, and in second, like 12, 20, 12, 34, and 37, 90, and in third, like this and this, comparing all those indexes like the manner which I said, and we'll calculate the minimum of the maximum. Like yeah, minimum of the maximums, and we'll return the maximum minimum, right? So this is the question. Now let us discuss the optimal approach. Like what's the optimal approach is binary search. How can you say binary search? Like if you see the question clearly, like mere observation, we can see like 12, 34, 67 all are there. But in this question, can we see like there is a pattern? Like the pages allocated will always be like from lower to maximum itself. Like if you see this question, the pages allocated can be minimum, that is 12, and the maximum can be like it can be the whole array can be allocated to a single person. So we can see that during using the observation, that is 12. 12 would be the minimum, we can't go lesser than 12. And 90 plus 67 plus 34 plus 12, that is like 2 not, I think I wrote it somewhere. Yeah, it's 203. 203 would be maximum. Like if we say like it is two students, for two students it would be the minimum, right? 12 would be minimum. Like if you want to divide all the given books for one only single student, 203 will be the maximum. Like this will be the minimum, this will be the maximum. Okay, I think you got how the binary setup like will occur right here. I think now the problem is easy. Yeah, you got low and that is low and high index. Calculate the mid. Okay, calculate the mid, and then after calculating we'll check whether like is it possible to create like a minimum number of pages. Like is it possible for it to distribute for two students, or it is not possible. If it is possible, we will like divide, like we'll decrease and conquer, like yeah, we'll decrease that, and we'll check the answer for its the sub part low. So let us discuss. Yeah, the minimum, like that is minimum is 12 and the maximum is 203. And now when we derive on it, so that is 203 plus 12, what it is, 225, I think so. Yeah, 200. Wait a minute, let us take the calculator. Okay, calculator. Okay, we'll check it here. Okay, 12, it is minimum would be 12 and the maximum is 203. It is 215. If you divide it by 2, what will you get? It is 107.5, that is 107. Now if we take 12 and 20, 203, so let us check. Yeah, 12 and 203, mid would be 107. We'll check. If we take 107 as the minimum number of pages, we can divide it for two, like two students. If we check like 12 plus 37, the yeah. If we check, right, yeah, that is 12 plus 34 plus 67. Will it violate? Yeah, it violates 107, right? And so it violates, we will make this one group and this as one other group. But if we check 67 plus 90 is far greater than 107. So we'll like far greater than 107. So what we have to do, increase the left counter. That is, yeah, that is what, left to mid plus 1. Now 108 and 203, that is, yeah, 108 and 203. In this case, 108 plus 203, that's 311 divided by 2. What's that is divided by 2, where it is divided by 2 will give 155. We'll check whether 155 we can divide it for two index. Yeah, this would be one part and this would be another. So it is one of the possible answer, 155. So what we'll do, we'll decrease the high pointer to mid minus 1. So now that is 108 till 154, I think. 108 till, yeah, 154. Now 1 108 plus 154 divided by 2, that's 131. We'll check for 131 whether 131 is feasible solution. Yeah, it is, because if you see 12 plus 34 plus 67, that gives what it gives, happening. Okay, 12 plus 12 plus what's happening? 12 plus, let me clear it. 12 plus, okay, okay. Ah, now let me check. 12 plus 34 plus 67. What it gives? 113. 113 is less than 133, right? 113 is less than 131. So we will decrease now further 108 till 130. Now, like that, we will decrease, and in next case, what will happen is like 108 plus 130. What will happen? 108 plus 130 divided by 2 gives us 119, and 119 is an answer. So we'll decrease 108 till 118. Similarly, after many such iterations, 113 would be the possible answer. That is the minimum of all the maximums. So this is what the question states. I think you all understood the question. Uh, let's write the code. Okay. In the code, what we have to do first, what I said is we will calculate the low and high index, right? So let's assign the low would be like first element first, like just for assigning, and int high would be like 0. Okay. Now, yeah, instead of assigning this, we will assign a of 0. That is first element. We will assign first element as a minimum element. Okay. Now I will change this for small letter for easy like typing. Now we'll assign low as a of 0, and now after assigning high, what we'll do is we'll calculate the mid like low element and high element. So we'll run for loop for int I is equal to 0, I less than n I plus plus. We'll calculate low and high pointers. That is, low would be math.min of, that is, a of I comma low. What this statement does is assigns the lowest element of all the array. Now high would be, like, high would be the summation of all the index. So that is a of I. There is nothing more than this. So we got that is low, that is 12 and 203. So this part is over. Now we'll store, like we will calculate the result, right? Int result will be 0, like -1. We have to return -1. So now after assigning result, what we will do is we will calculate the, what would you calculate? We'll run the binary search template, right? After calculating the high and low, we'll run binary search template. So we will run while, what we have to run is what the binary search template states here. It is always low lesser than or equal to high. Now low would be lesser than or equal to high. Now, like, we'll calculate the mid. Obviously it's a binary search question. Low plus high minus low divided by 2 is happening. Okay. Low plus high minus low divided by 2. After calculating the mid element, we'll check whether it is a possible answer. So we'll write if, like, possible. What we have to pass? We have to pass a, n, m, and also mid. We'll pass this, like we'll assume this function is already written, and we will say if it returns true, then it would be a possible answer. Okay, if it is a possible answer, we'll store it in the result variable, and will, if it is a possible answer, we have to calculate the minimum of it, right? So we'll assign high as mid -1, and if it's not, Obviously, everyone knows the answer. Low would be mid plus 1. Until now, you are clear. Like, yeah, low would be mid plus 1. Finally, what we have to return either low or high. Both would be like pointing at the same index. Now, we'll write the function. What the function is like. We'll return a function of Boolean data type, that is public static Boolean possible. What we have paused, that is array. We have paused array, and we have passed n and m also, and mid also. Like, this is the function. In this function, what we have to do, like, if you see the, like, yeah, see the explanation. In this function, we'll check, yeah, we'll check whether this element belongs to, like, is it possible by calculating the number of students. So we will, to like keep the track on the number of students, we'll create a variable that is count as 0. And now, after keeping the track of count as 0, then we'll run a loop. It is for, yeah, to calculate the sum also, like, is it a feasible one. So so we'll make another variable that is sum. We'll run a loop that is for int I is equal to 0, I less than or equal to less than n. Plus, we'll check what we have to check. If sum plus fi is greater than mid, is it greater than mid? Like, we'll check if it is greater than mid, then what we will do, we'll simply increase the count. And also, we will assign sum as that element. I will explain it now. And after calculating the sum as that element, we'll check if that sum is greater than mid. If it is greater than mid, it would not be possible for like making the answer. So we will return directly false. Else we will directly, like, we will add the element that is sum plus equals fi. So, yeah. Finally, after calculating all this, we will check. What we will check, if the count is lesser than m. If the count is lesser than m, then obviously we will return true. If it is greater than m, we will return false. So why I written this is, so let me explain this part. Yeah, let me copy. We Okay, let me explain this part of the code. So what this code states is, like, first we will assign a counter variable. Like, for this only, let me take this 15, 17 and 20. 15, 17 and 20. Now what would be the minimum element? Minimum would be obviously 15 and maximum would be 15 plus 17, that is 32. 32 plus 20 is 52. If we calculate the mid, that is 15 plus 52 by 2. 15 plus 52 by 2 is 33. Okay, we will check. So now we will pass 33 in the mid element. Now the count is 0. Okay, sum would be 0. Now we will run a loop for int I is equal to 0, I less than n, that is 50. It will be pointing right here. It will be pointing right here from 15 to 20. Okay. Now it would be like sum plus AFI, is it greater than it? Now the sum is assigned as 0. That is 15. Previously the sum was 0. That is 0 plus 15. 0 plus 15. Is it greater than 33? No. What we have to do? We have to add sum with AFI. Now the sum would be 15. Now in the next iteration at this index, 17 plus 15, is it greater than 33? No, obviously not. So 32, it would be 32, right? 32, is it greater than mid? No. Count plus plus. No, 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 no. We'll increment the sum, that is 32. No. We'll calculate at the next index, that is 32. 32 plus 20, 52. Is it greater than mid? Yes, obviously it is greater than mid. That 33 is there, here 20 is there. So count plus plus, count will be 1. Count previously was 0. Count would be 1. Count. Okay. Previously it was 0, now we incremented it to 1, and after making 1 we'll rewrite the sum as that index in which it was violated. It was violated at this index, right, at 20. So we'll assign 20 as the sum in this case. And now we'll check whether 20 is greater than mid. Is 20 greater than 33? No. Why I'm doing this is because it, like, if it is greater than the single element, if the element is greater than the mid, then how can it be possible answer? So I am returning directly false. Now else sum plus plus, and after all the loop, after completing this loop, this one, we'll check if count is less than m. Yeah, count was 1 and the students given was 2. Yeah, it's less than m. We have to return true. So yeah, this was the answer, right? 32. I think 32 was the answer. Yeah, 32 was the answer. So that is the thing. Let me submit the code. I think you all understood this. Let me check. Is there any errors? Yeah, it's running fine. Let me submit it. Like, I hope, yeah, it is not running for what test case. Its correct input was, what its correct input was, like it was -1. Yeah, I think high would be mid -1. Yeah, it is correct. Then what did I miss? Result is equal to mid, written low. Its correct input was like -1. Why I'm missing? I think if we, like, yeah, here I think I missed that thing. Result. Uh, okay, let me copy this test case. Control V. Now compile and run. Its previous expected output difference. Why it is 90? Why it is 90? Okay, yeah. Hmm. Here they had given my output is 90. Yeah, I missed one thing right here. What I missed was, like, we have to return -1. In which case we have to return -1 when the given students are more than the number of, like, pages, right? So this was one test case which I missed. If m is greater than n, then obviously we have to return -1. So this is why it was failing the test case, I think so. Hopefully it should run right now for the particular input. I think it should run. Okay, run no Java. It's evaluating. Yeah, it's giving the correct input for the test case. So now let's submit it. Like, this was one of the toughest problem. It took me around 1.5 to 2 hours to understand this question and also deliver to you. So yeah, this was, like, prepare it very, like, with concentration. Like, this type of questions will be appearing in your OS, like, yeah, online assessments in many big tech giants, that is product based companies like Microsoft, Google. Coordination frequently asks this question, like in previous grid, that is Flipkart grid 4.0, this question was asked. Aggressive curves, but it was a variation, that is like pigs. Yeah, it was like pigs problem. It was something related to pigs. If you recall, like, the same thing was happening in this problem. You can obviously solve this question. So I was missing this single line, so that was, like, happening. So that is the thing. So now, yeah, do like, share, subscribe to my channel. Thank you guys. Thank you.